Every working morning begins the same way. People arrive, systems wake up, and work begins. For most of computing history, software waited for us. It answered questions, it returned results, it did what it was told, one instruction at a time. Artificial intelligence is changing from something we ask questions into something we give authority. A single sentence. Analyze our infrastructure risk. Identify the systems that need remediation. Prepare the executive report. One human request can become hundreds of machine actions. The agent retrieves data, it calls APIs, it queries cloud services, it reads security telemetry, it invokes tools, and it makes decisions at machine speed. No individual step looks unusual. What is new is the scale, the speed, and the fact that no human is reviewing each one. We know who authenticated the human. But when an autonomous agent begins acting across the enterprise, a different security problem appears. Who is the agent? What authority does it hold? And can it still be trusted? These are not philosophical questions. They are access control questions. And most enterprise architectures were never asked to answer them. Security models were built around a familiar cast: human administrators, service accounts, applications, workloads. AI agents now join them as a new class of privileged digital identity. They can operate independently. They can inherit authority from the humans who launched them. They hold credentials, call tools, reach sensitive data, and interact with systems that people rarely touch directly. The risk is not that the agent is malicious. The risk is authority that is too broad and lasts too long. Traditional security establishes trust at a point in time. Authentication succeeds. A credential or a token is issued, and trust persists. But conditions do not remain static. Device posture changes, behavior changes, tool access expands, new interfaces appear. The context that justified the original decision quietly disappears. The session, however, is still marked trusted. Consider a plausible scenario. The agent begins within its expected pattern: asset inventory, security events, a risk database, everything authorized. Then the pattern shifts. A request for 500,000 records, an unfamiliar destination, a tool it has never used before. The credentials are still valid, the session is still authenticated, but the behavior, the environment, and the authority have changed. So should yesterday's trust decision still apply? Answering that question requires 5 architectural capabilities. First, identity. Every autonomous agent needs an identity of its own. Not simply the identity of the human who launched it, and not a shared secret buried in a configuration file. Delegation should be explicit, attributable, and revocable. Second, authorization. Authority should be scoped to the task, the resource, and the context. Reading an asset inventory is not the same privilege as creating an administrator, modifying a network policy, or changing industrial control logic. Third, continuous verification. Trust should not be established once and assumed indefinitely. Between the human and the agent, between the agent and the model, between the model and the tool, between the tool and the API, and between the API and the data. Each boundary is another opportunity to verify identity, integrity, authorization, and context. Fourth, policy. A decision engine should weigh identity, integrity, behavior, context, and risk, and respond proportionally. Allow, limit, step up verification, or revoke. And fifth, evidence. Every significant action should be attributable, reviewable, and auditable. Not a log written for convenience, but a record built for accountability. Identity, authorization, continuous verification, policy, evidence. Together, they describe continuous trust. An autonomous agent does not perform one action. It moves through a chain of identities, models, tools, APIs, and data. At every boundary, identity can be resolved. Authorization can be scoped. Trust can be verified. Policy can be applied, and the action can be recorded. Every hop is a trust decision. In high-consequence environments, the question becomes heavier. Energy, water, manufacturing, transportation, places where a software decision becomes a physical outcome. An AI maintenance agent may legitimately read from an engineering workstation or query a historian, but should an autonomous agent be allowed to modify an industrial process simply because it holds valid credentials? In operational technology, the responsible architecture is monitor first, act carefully. High-impact actions should require human approval. Autonomy should stop at the boundary where consequence begins. QuantLayer is BData's AI-orchestrated zero-trust and continuous trust platform. It is designed to establish and continuously evaluate trust across users, devices, applications, workloads, networks, cloud, OT, IoT, and autonomous AI identities. 3 ideas sit underneath it: immutable identity, continuous authentication, and continuous trust. From those, policy, segmentation, response, and evidence follow. Instead of assuming that a previously authenticated entity remains trustworthy, trust can be reevaluated continuously as identity, integrity, behavior, and context change. Continuous trust does not require an organization to discard the security investments it already owns. IAM, EDR, and XDR, SIEM, mobile device management, network access control, firewalls, OT monitoring, cloud security, these remain. QuantLayer is designed to consume their signals, establish identity and trust context, and return a trust state that existing control points can act upon. The future enterprise will not consist only of human identities. It will contain users, devices, applications, workloads, machines, and autonomous agents, all interacting continuously. Every digital entity is becoming an identity, and every identity requires trust. AI is no longer just generating content. AI is taking action. And anything that can take action needs identity, authorization, and continuous trust. Trust everything less. Verify everything continuously.